All right.
Okay. First of all, let me take a snapshot of this so I can draw on it. If we're looking at 17, the only thing we really need, notice that all 6 of these functions have an amplitude of 2.
Yeah.
So that's not going to help us at all in differentiating between them. However, they all have different periods, and some are sine curves, some are cosine curves. So that's what we're going to figure out, is what the period of this is. What's the period of that? 17.
1/2.
No, that's B. Here's what you're dealing with. The period is always 2 pi over B, or B is 2 pi over the period. Both of those things mean the same. Algebraically, one converts to the other. So we have B in this case. B is 1/2. In other words, B is always the coefficient of X. So if you have B, what is the period?
1.
What's 2 pi divided by 1?
Pi. Or pi, sorry.
No. What's 2 pi divided by 1/2?
Divided.
2 pi divided by 1/2. How do you divide by a fraction?
Multiply.
So what's
I can't remember.
Multiply by its reciprocal. You flip and multiply, right?
Mm-hmm.
So 4 pi is the period.
Okay.
Now, let's find a sine function that's got a period of 4 pi. Well, that's a tangent function. That's a tangent function. That's a cosine function. So we got 3 choices, A, B, or D. Which one has a period of 4 pi?
It can't be A because that's a cosine function.
You're right. That's a cosine function also. So that one can't be. But we don't really need to do this by process of elimination. It's B. The period of B goes from 0, and this point is 4 pi. In other words, every 2 grid marks is pi. So that's pi, that's 2 pi, 3 pi, 4 pi. So B fits. B has an amplitude of 2 and a period of 4 pi. So that's B. Okay. Now, let's look at 18. Like I said, there's no point in dealing with the amplitudes because they all have amplitudes of 2. So the only thing we really need to figure out is the period. Which curve has a period that goes with a B of 1/2? What's the period again?
4 pi.
4 pi. Where is there a cosine curve that has a period of 4 pi?
E.
Correct. So that's E. 19. What's the period on 19?
Sine of.
First figure B.
It would be pi. The period would be pi.
Okay, where do we have a sine curve with a period of pi?
D.
D, did you say, as in David?
Yeah.
Okay, good. Now, 20. Now, let's do 21 next. Just let's get rid of all the sines and cosine curves. What's the period on 21?
21, that's going to be pi again.
What curve is a cosine curve with a period of pi?
A.
Okay, so that's A. Now let's look at our 2 tangent curves. Now, they both look the same, but notice they have different periods. C has a period of pi over 2. F has a period of 2 pi. You see why?
Mm-hmm.
Now, the difference is with tangent, the period is not 2 pi over b, it's pi over b. In other words, one full cycle of tangent is pi, normally. In other words, if you draw a curve with a b of 1, your period is going to be pi with tangent. It's not 2 pi over b, like sine and cosine are. So,
Okay.
let's look at 20. What's the period going to be on 20?
It would be 2 pi.
Which curve is that? C or F?
I think it's C.
Measure the period. The period goes from that asymptote to that asymptote. In other words, tangent just repeats. Every one of those is a period. So this period from there to there is 2 pi.
Okay.
This period from here to here is pi over 2. This one, number 20, gave us a period of 2 pi, so that's F.
Mm-hmm.
Number 22, it's pi over 2, b is 2, so we've got a pi over 2 period, and that is C. All right, let's see, that's everything on that page. The next page he and I did, I think, was this middle one. Let's see if that's what you want to do next also. 23, we didn't do all,
Sure.
I think we got through 31 is what we got through, yeah, before we ran out of time. It's probably going to be the same for you and I. So, amplitude. Let's talk about amplitude. In other words, they haven't taught you the 4 variables yet with a sinusoid function. But what they have taught you is just amplitude and period. In other words, A and B. So what they've given you as a standard is y equals A sine of bx. That's the only thing they've worked with so far. They don't have any phase shifts and they don't have any vertical shifts. Probably next year is when you'll get that part of trig. Amplitude, really easy to remember. It's the maximum value minus the minimum value, don't drop any negative signs, divided by 2. Always, that's what the amplitude is. That's what A is. Okay?
Mm-hmm.
So, what is A on 23?
23. It'd be 1.
Correct. What's the period on 23? Each grid mark is a pi.
So 3 pi?
Count them up.
Oh.
In other words, it's got to go from where it starts to where it begins. Next cycle. It's very important.
Okay, so 6 pi. 6 pi.
6 pi, exactly. And you don't necessarily have to go from that point to that point. If we had more periods represented, we could go from peak to peak. It's just that we don't have 2 peaks. So we kind of have to go from that point to that point. Okay. Number 24, what's A?
4, 0.5.
Or 1/2. And what's the period?
2 pi.
See, they're trying to fool you here.
2.
The period is just 2. In other words, the x scale doesn't always have to have a pi in it. It's in radians. And radians are numbers. So even if I say pi over 2, that means 3.14 divided by 2. So it's really just a number. But don't be fooled into thinking the x-axis always has to be in terms of pi. It doesn't. It can be in numbers, just like this one. And 25, what's the amplitude? You might have to look at the book to see for the period, but
It's 2.
No, what's the...
No, 4, sorry.
Okay. And what's the period?
Period.
You can barely see it on here. Now this one you can go peak to peak. In other words, go from that peak to that peak. Read that? That's pi right there.
It's pi? Okay, I can read that.
Well, that's pi over 2. That's halfway. So,
yeah.
Okay. So that period is pi. And now let's do 26. These are real easy. What's A?
1/2.
What's the period?
Pi.
That's B.
Oh, so it's B, 2 pi over B.
So B is pi. Yeah, the period is 2 pi over B. So 2 pi over pi, 2 is the period for 26. What's the period for 27?
1. Oh, the period. Okay, I'm sorry. So
No, that's
2 pi over 2, so it's pi.
Okay. I'm going to assume you know what A is on each of these.
Yeah, okay.
So we'll just do the periods. What's the period on 28?
2 pi over 1 plus, so multiply by 4, 8 pi.
Period on 29?
4 pi.
30?
4 pi squared?
No. What's B on 30?
1/2 pi.
Right. Or I can write that as pi over 2. So the period is 2 pi divided by pi over 2. Flip and multiply, you get 4.
Oh, okay.
Pi's will cancel, but I've got 2 times 2. So the period is 4 there. That's a little tricky. They're trying to trick you by putting 2 coefficients in front of x, but it's really just pi over 2 is b. Okay, and 31, b is 4 pi. So what's the period
pi over 2.
What's that?
Pi over 2.
If b is 4 pi, and the period
2 pi
is
over
equal to 2 pi over 4 pi.
Oh, 1/2.
Okay.
Sorry.
It's all right. So you're kind of seeing what's going on here is that when b has a pi in it, the period ends up being a number. When b is a number, the period ends up having a pi in it.
All right.
You get what I'm saying?
Yeah.
In other words, that is going to have a period that's a number without a pi. That's going to have a period that's a number without a pi. That's going to have a period with a pi in it because b is a number. B doesn't have pi in it. Okay. Now 32 through 43 is perhaps the one area of mathematics where it's hard to do online and it would be easier to do in person. If I was in person, I would have you pull out a piece of paper and graph each of these. The best we can do online is I'm going to have you tell me how to graph it. Okay? So it's a sine curve. So I'm going to draw a sine curve. And now I just need you to label the x-axis, because you can do that based on everything you're seeing in that function, and also label the y-axis.
So the period is, so the y-axis, the amplitude is 1.
So that high point is 1, the low point is -1.
Is -1.
Okay.
And then the period is...
Let's label this point right here, because that's the period.
Yeah, that's going to be 8 pi.
Okay. And a proper labeling job on these means you quarter it up. I don't know if they've worked with you on that or not.
Yeah.
In other words, I want all 4 midpoints. That's got to be 4 pi. This is an important midpoint because that's where the sine hits its peak. That's 2 pi. This is an important midpoint because that's where the sine hits its minimum. That's 6 pi. This is an important point because that's where it starts. It's 0. So really, you always have 5 labels on your x-axis, truly, when you're doing this on your own, when you're graphing them. In other words, the way to do it is to find your beginning point, find your ending point, quarter it up, and then you know how to graph it. Okay?
All right.
The next one. I'm just going to leave my graph there and change the numbers. First of all, no, I knew that was going to happen. It's cosine curve. So I'm going to draw a cosine curve. Before I draw the cosine curve, let's do the other stuff first. I want to give you a better way of drawing this thing. What's my ending point?
10 pi.
Okay. So I'm just going to arbitrarily make an ending point over there of 10 pi. Now I have to quarter that up. So let's quarter it up first. What's the middle thing?
5.
What's the first quarter point?
2.5.
Now let's call it 5 pi over 2.
Okay.
Much prefer improper fractions than proper fractions. This is what? 15 pi over 2. The way you get these midpoints is you add the two numbers and divide by 2. So I got that point by adding 5 pi to 10 pi, which is 15 pi, divided by 2. Okay? So now we've got the x-axis label. Amplitude is 1, so I know that's 1 and that's minus 1. Now, here's how I would graph it if somebody told me to graph it. I know that cosine starts out at its maximum value, so I'm going to put an X right there. I know at the first quarter point it goes through the 0 line. The second quarter point it hits its minimum. At the third quarter point it goes back through the 0 line, finally comes back to its start. Now you just connect the dots with what you think looks like a cosine curve.
Yep.
You've seen enough cosine curves to know that it looks something like this. But when these get hard, this really becomes helpful, is to figure out your x-axis, label all 5 points that are key points, and your y-axis, your maximum and minimum point, and then draw your points where you know the function starts, goes through the zeros, goes to its minimum, and so forth.
All right.
All right, we got 2 minutes. I'm going to do one tangent curve, number 34. First of all, I know that tangent has asymptotes that are symmetrical about the y-axis. And this is just one period of tangent. And it's always increasing from negative infinity to positive infinity, never quite touching those asymptotes. If I wanted another period of the tangents, I would draw another asymptote. That thing goes like that, okay? But we don't need 2 periods, we just need 1. Now all I got to do is label this. Well, traditionally, if I just said y is tan of x, then this goes from minus pi over 2 to pi over 2, giving you a period of pi. Okay? Well, they want us to label 1/4 tan of pi x. So what's the period going to be? First of all, tangent's not like sine and cosine. With sine and cosine, the period is 2 pi over b. With tangent, the period is pi over b. Because one period of tangent is only pi big. So the period is pi over b. Okay, so if b is pi, what's the period?
What is, so
Here's b, the coefficient of the x term. So what's the period? What's pi over pi?
1, so 2.
No, 1 is the period. Remember, the period is pi over b. That's all you need to know. Period is pi over b, and we can see that b is pi. So I plug in pi for b, and I get pi over pi, so the period is 1. Now, the period is 1. What does that make my x-axis? What are those two asymptotes? Where are they at? If my period is 1, yes. Minus 0.5 on the left, plus 0.5 on the right. Now, the amplitude of 1/4 is the same as a vertical shrink factor, correct?
Yep.
That's what A is. I don't know why they insist upon calling it different stuff, like amplitude. They should just stick, that's a vertical stretch or a vertical shrink factor. Well, this is a shrink, which means if I wanted to draw a tangent curve that had been shrunk, it's going to look far more like this.
All right.
Notice that every point on the red is closer to the x-axis by what I was trying to do, 1/4.
Okay.
So it has to be a shrunk curve. All right. Cole, are we back to, when are we going to do on Mondays? What works best?
Next week on, I can do the 3:30.
Okay, let me make
You can
sure.
go back to 3:30.
Let me make sure I've got that in my calendar here before I let you go here. Yeah, I got you at 3:30 the rest of the semester.
Yep, that'll work for me because I don't have any. This is show week, so.
Sounds good. I'll talk to you next Monday.
All right, thank you.
All right.